A tree is a collection whose entries have a hierarchical organization. Here's an example of a tree. Each item in the tree is called a node. Each node can have 0 or more children. A node can either be a leaf or an internal node. A leaf node or the nodes in yellow are the nodes without any children, while the internal nodes are the ones with at least one child. The one highlighted in red is an example of a node without any child. One kind of tree is a binary tree. Here's the structure of the binary tree. Each node in a binary tree has at most two children. The order of values or the arrangement of values in a binary tree is not important. A special type of binary tree is a binary search tree or a BST. The difference between a regular binary tree and a BST is the arrangement of values in a tree. Here are the properties of binary search trees. Number one, the values in the left subtree are less than the node. So here's an example. If the node is 10, 1, 3, 7, 5, and 9 are less than 10. The values in the right subtree is greater than the node. If the node is 10, the values 15, 13, and 20, which can be found at the right subtree, are greater than 10. And finally, each subtree is also a binary tree. So for example, this subtree right here is also a binary tree since 5 is less than 7 and 9 is greater than 7. Binary search trees are used to store a sorted list of values for efficient searching operation. Addition of new and deletion of values while maintaining the sorting can also efficiently be done in binary search trees. So let's try this example. We are asked to insert the following values to an initially empty binary tree and BST: 18, 3, 9, 45, 32, 1, 20, and 5. So we are going to simultaneously insert them to an initially empty binary tree and binary search tree. So for example, we insert 18. We have two trees with one node. 3 is inserted at the left of 18 for both BSTs and binary tree. And then 9 is inserted at the right of the binary tree. But for the binary search tree, since 9 is less than 18 but greater than 3, 9 becomes the right child of node 3. And then 45. Since 45 is greater than 18, 45 becomes the right child of 18. And then 32, 1, and then 20, finally 5. So the one at the left is your binary tree, and the one at the right is the binary search tree.